So welcome back to our channel. So these days we get a lot of calls from a lot of you people asking that we need an AI workstation, we need an AI box like the DGX Spark or the MSI version of it or the ASUS version of it. But the real question you're asking yourself before buying is, what do I actually need for my actual workload? Because AI workloads are kind of split into two different buckets, and both these buckets require a different kind of hardware. Really. And if you make the wrong choice, you're actually wasting a lot of money. So today I'll attempt to explain the different workloads and what kind of system requirements are there for each of them. So there are two primary AI workloads. Make a quick mental model to understand what these are. Padhai is kind of training, and doing the Naukri is actually the kind of inferencing workload that we see. So yeah, clear? Training Padhai, inferencing Naukri. Simple. Not so simple for the hardware. So when you train a model, the model sees an example and tries to give an output. That output may not be correct, so you kind of nudge it towards the correct answer. And when you're actually nudging the model towards the correct answer, it's adjusting a lot of its internal weights, which are nothing but numbers. And this adjustment happens millions, maybe billions of times. Billions. So you make a forward guess, do a backward correction, and then this is kind of known as backward propagation. This actually puts heavy load on your system. VRAM, compute, everything. And inference never really does the backward correction because it's already trained, it already knows what to do. Because the weights are frozen, you get the input and boom, you get the output. That's more or less it. Just like answer, answer, answer. If model galat train hai to galat answer. Naturally. So here's the part nobody tells you. For example, if you're running a model which has 16 GB worth of weights, you would assume that 16 GB of VRAM or slightly more 16 GB of VRAM is enough. That's enough. That's all you need. But that's not the case when you're doing training. It might be enough for inferencing, but training is a different ballpark altogether. So to do the backward correction, not only does the model load up all the weights in the VRAM, it also needs extra memory to actually nudge the model in the correct path. And for that, they actually need more memory. And modern optimizers actually run 2 values per weight. Basically, you end up needing 3 to 4 times more VRAM than the actual model memory weights, if that makes sense. So the same model that infers 16 GB very happily will probably not train on 16 GB VRAM. It's just not happening. Zyada memory chahiye hoti hai training ke liye. In short, so a training machine is kind of built around that reality that you need max compute, max memory, max VRAM as much as possible depending on the model you're trying to train. That's the reality. It generates a lot of heat and probably requires decent cooling solutions. Also a reason why people are running out of water wherever data centers are installed. That's actually happening. But that's out of the scope of this video. We're talking about on the desk wala training and on the desk wala inferencing. When you actually think about the inference workload, it actually kind of flips your priority. Now you don't need that max compute. Now you don't need that extra VRAM. Now you don't need that huge system memory. That's why these AI boxes are becoming popular. Please do keep in mind these AI boxes, the DGX Spark is an inferencing thing. Please, it's not for training. Not really.
Same.
Not really, bro.
Then why it has 128 GB RAM?
For model size, how will it run a bigger size model?
128 GB RAM means.
So for an inference box or an inference machine, what you need to make sure is VRAM plus RAM is actually able to fit the model comfortably. That's all it needs. That's it. If you want more context length, you kind of need more RAM. So what really matters in an inference machine is latency. Yes, latency. Time to first token and actual tokens per second that you get after that. So end-to-end latency is from the time you hit enter until the time you get the final output. For example, time to first token might be 1 second. But what if your token per second is just 10? That doesn't help, does it? दोनों भी चाहिए अपने. ये हमें enter मार के चाय पी के आओ, चाय पे आ रहा हो thinking cloud वाला. So yeah, naturally, inference machines or inference boxes or inference workstations kind of run cooler, don't require as much power as you would need while training something massive, basically.
But inference itself would require CUDA cores or tensor cores or
GPU, right? GPU compute, basically.
GPU compute.
Yeah.
So जितना अच्छा GPU उतना ज़्यादा token.
Yeah, obviously, right? Naturally. So the natural question is, why not make one machine that does both? Yeah, cool, definitely can, but do you really need to is the question, because you could just train your model in the cloud and then just download it once it's trained and run it on inference box. Probably will be cheaper in the long run. depends on how much training do you think that you're going to be doing. If you're not bothering with training at all, maybe you don't need that huge ass machine. Just fit your model. And of course, most open source models allows you to kind of reduce the model size to make it fit in your box, whichever box you're running, whichever desktop you're running. So that kind of flexibility is available with inferencing, but not with training, because पढ़ाई तो मेहनत ज़्यादा ही लगती है लाइफ में. Coming back to our mental model, right? So yeah, when somebody asks us that we need a AI PC or AI workstation, what we ask you is, what are you actually doing? You need a completely different machine from when you train and you inference. So yeah, do keep that in mind. And to be very honest, in both cases, this reality of spending matters, because you own the machine once and keep doing work on it forever, or just rent it from cloud and keep paying subscription forever. So that's totally down to you. And in my opinion, it's much better to own your hardware than renting it from the cloud. What if internet goes away? What are you gonna do then? Deep research nahi ho payega. But yeah, so that was us trying to explain what kind of different hardware you need between training and inference. I know this was slightly confusing. So yeah, thank you for watching. Have a great day, guys. Peace.
एक्चुअली मेरे को एनवीलिंक का एक सवाल था कि लाइक मैं जब अपन ब्लैकमेल का वीडियो डाले थे तो बहुत लोग बोलते थे अरे एनवीलिंक कहीं तो नहीं डाले, तो
डालना चाहिए था.
रिसर्च करा. एक्चुअली तो 6000 में नहीं है ब्लैकमेल.
6000 प्रो ब्लैकमेल में है ना? नहीं है.
और इनका लोगों का रीजनिंग ये है कि पीसीआई इतना फास्ट हो गया कि उसी से डाटा ट्रांसफर हो जा रहा है.
हाँ, तो फिर डेटा सेंटर में क्यों कर रहे हो लोग? नहीं ब्रो, चाहिए रहता है एनवीलिंक. इट्स बेसिकली अगर मॉडल ट्रेन हो रहा है, अलग जीपीयू में अलग पार्ट हो रहा है, अलग जीपीयू में अलग पार्ट हो रहा है, एंड में उन लोगों को कम्युनिकेशन करना पड़ता ना, तो कम्युनिकेशन फास्टर रहा तो ही अच्छा है, राइट? इवन इन्फ्लुएंसिंग मशीन का ये सीन रहता है कि अगर दो अलग अलग जीपीयू में कर रहे तो उन्हें दो अलग जीपीयू में करके फिर एक उसमें लाता, फिर काइंड ऑफ लाइक एफिशिएंसी लॉस होता. इसलिए यू आर मच बेटर ऑफ विद वन बिगर जीपीयू देन टू स्मॉलर जीपीयूज विद द सेम मेमोरी.